Hello, my name is Jillian Orisano, and I am a graduate student in computer science at the University of Illinois at Chicago. And this is a program that I wrote for a GPU programming class. And it uses OpenGL and GL shading language to read in video from a webcam and alter that video using shaders. There are 3 pages of shaders in this program. And you can move between pages by pressing 1 to look at page 1, 2 to look at page 2, and 3 to look at page 3. On an individual page, you can focus on individual shaders by clicking on them, or by pressing Q, W, A, or S, and Z returns back to the full view. Now, on this page, there are 3 effects. In the upper left-hand corner is the regular video feed, which can be used for reference. In the upper right-hand corner is a cartoon shader. To produce this effect, I read in the video. I emboss the video in order to generate these edges that you see here. And then I blur the video in order to create a more sort of sketchy appearance. And then I posterize, taking the continuous color range and breaking it into discrete categories in order to create a more blurry, chunky sort of effect. And as you can see, elements in the room appear to be outlined, appear to be drawn, and it mimics a cartoonish look in this video. This shader is an old movie shader, and what it does is it takes the video and adjusts the brightness with respect to the distance from the center of the image. And the degree of darkening varies over time. I send in a timer from the start of the program, and it creates a flickering effect. I also have some noise in these sort of bits of these darkened pixels, and I also create a jostling effect by having the frame shift every 20 seconds or so. I created this shader using a fragment shader. I didn't need to use any effects within the vertex or geometry shader. And that's true for all of the effects on this page. The shader in the lower left-hand corner is a light bright shader. And it works by dividing the space into light bright pins and then computing the average color within each pin and assigning a light bright color based on the computed color. I used saturation and value in order to decide which light bright color to associate it with the computed average color in each pin. And that way I'm able to define the features of the view using these sort of gradations in color. So you can see elements primarily by the differences in color and then the black versus the colored pins. And this is consistent with much of the light bright art that I saw, and so I thought this would be a good way to transform the image into something interesting and unique. The second page of shaders, in the upper right-hand corner, I have a funhouse mirror, and it warps the image according to a sinusoidal function. I do this by transforming the texture space so that it moves from -1 to +1, and then you alter the texture mapping, and the degree of variation will be more extreme in the center because it's closer to 0. And so here you get a sort of varying funhouse mirror look. On the bottom here, I apply a lens filter and to distort the image, along with applying chromatic aberration. And what that means is that I vary the sort of distortion in the chromatic field in a variable way in red, green, and blue. So as you can see near the edges, the red pixels are shifted, more so than the green and more so than the blue. And this is done to mimic the effect that you might see if you're looking at an image through a highly warped lens. The shader down here is a bump map shader, and what I did was I embossed the image and used those values to modulate the normals so that the light reflecting off of the image is variable, which creates a textured appearance as if something had been etched into the surface of a piece of metal. And that's the second page of shaders. And on the third page of shaders, in the upper right hand corner, I have sort of a collage effect. And my thinking here was that I wanted to break down the space into these rectangles and then vary what part of the texture each of the rectangles was pulling from. So it creates a sort of collage look. It actually sort of reminds me of something that you might see in sort of an 80s sitcom, the final frame for the main character. It's very, it's also very sort of self-centric, this frame. It's all about the person in the middle. And so I varied the color mapping in each rectangle, which creates a sort of collage like look. For this shader, this is a wave shader, and I used a sort of sombrero hat function to modulate the texture mapping, and it looks like the image is composed of water. And you can move the center of the distortion using your mouse. And this creates a kind of fun effect. Modulates the image, and it really looks like there is a puddle of water atop the image. And then the final shader, the shaders prior to this used vertex shaders and fragment shaders, and this one uses a geometry shader. And what I did here was I broke down the image into 3 triangles, and then I send those 3 triangles to the geometry shader, which in turn subdivides each of those triangles into 9 additional triangles and modulates the way in which those triangles map to the original image according to a function in terms of time. I also modulate the color mapping. So each of the vertices in the corner have a color: pink, yellow, blue, and orange. And the way in which the colors are mixed varies over time at each of the newly generated vertices within the geometry shader. And so this creates a sort of dynamic crystal effect where the background image is warped in a variable way, and the color of the sort of crystal also varies over time as well. And I think this is a fun use of a geometry shader. And that's my program. You can refer to my website for more information on how it was generated. Thanks so much.